Hey, it's Sukrit from STEM Coder, and today we're going to talk about the chain rule. So over here we have our function f of x is equal to the sine of x squared. Now we may not know how to take the derivative of sine of x squared off the top of our head, but why don't we break this up into two functions, a of x which is just x squared and b of x which is the sine of x, and we write f of x as a composite function, a of b of x. So we're basically taking the sine of x which is b of x squared, sine of x squared. Is there an easy way to take the derivative of composite functions? Well, let's find out. Before we get started, we'll cover some variables we'll be using today. X will be the input to the inner function, so in our case b of x. U will be the output of the inner function and the input to the outer function. So in this case it will be the output to b of x and the input to a. And y will be the output of the outer function, so the output of a. So we feed in x to b of x. Then b of x will output u, we feed u into a, and a will output y. Well, that's what we're using, and you can see u is kind of this intermediate variable, what's passed from the inner composite function to the outer composite function. So let's get started with our proof. Over here we've got our standard limit definition of the derivative, but instead of writing f of x plus h minus f of x, I'm going to write delta y, and instead of writing h, I'm going to write delta x, because ultimately what is h? It's just a change in x, right? And instead of taking the limit as h goes to 0, I'm just going to take the limit as delta x goes to 0, because, well, delta x is just h. I'm writing delta y because technically this is just delta y, and that's going to become smaller and smaller as my delta x becomes smaller and smaller. So for our first step, we're going to break this up like this. So this is going to become delta y over delta u times delta u over delta x. This is fine because it's just fraction. These two cancel out to get delta y over delta x. So it's just the same expression. Next, we're going to separate this into two individual limits. That's a limit property. And now let's look at what we have on the right. On the right, we have delta u over delta x. The limit as delta x goes to 0 of delta u over delta x. Well, that looks an awful lot like this limit statement over here, right? And this is equal to dy over dx, the derivative of y with respect to x. So this over here is just the derivative of u with respect to x. So now we still have this statement over here we need to figure out. And this is the limit as delta x goes to 0 of delta y over delta u. Well, what do we do from here? Here's a cool trick. As delta x goes to 0, delta u also goes to 0. Why is that? Well, remember, this is a differentiable function, and as the change in the input as delta x as that goes to 0, the change in the output, the delta u in this case, that's the output of the inner function, that also goes to 0. So as delta x goes to 0, delta u also goes to 0. So we can basically read this limit much like we did this over here, delta y over delta u, as the denominator goes to 0. Well, what is that? That's just going to be the derivative of y with respect to u. So dy over du. And this is actually just the derivative of the outer function with respect to its input. This is the derivative of the inner function with respect to its input. So let's write that in a more familiar form down here. This is easy. This is just b prime of x, because ultimately x is the input and we're just taking derivative of b with respect to x. And what is this over here? This is going to be a prime, and it's going to be u as the input. But what is u? U is just the output of the function b, right? So instead of writing u, we can just write b of x over here. And this over here is our chain rule. If you are taking the derivative of a composite function, a of b of x, it's going to be equal to a prime of b of x times b prime of x. The derivative of the outside on the inside times the derivative of the inside. So let's repeat that. The derivative of the outside on the inside times the derivative of the inside. Let's run our example. Our outer function is x squared and our inner function is sine of x. So what are our derivatives? They're cosine of x and they're 2x, right? So we need to do the derivative of the outside, so that's 2x. On the inside, so it's not x, the inner is actually sine of x. And this is going to be times the derivative of the inside. And what is that? Well, that's just cosine of x. And this over here is the derivative of sine squared of x. 2 times sine of x times cosine of x. And we just use the chain rule to figure it out. So I hope you found this video helpful. Make sure you understand this chain rule well, because we'll be using it a lot in the future. And remember, the derivative of the outside on the inside times the derivative of the inside. That's the chain rule in a nutshell, and I look forward to seeing you in future videos.